Venn diagrams. When was the last time you did Venn diagrams? Have you done Venn diagrams before?
Like 5 years ago.
5 years ago?
4 years ago.
So it's about drawing circles and putting numbers in circles. It can be very helpful for figuring out probabilities and solving problems. Now, here is a very boring Venn diagram. You've got 100 students in grade 12. 38 of them do archery. So you have one event, which you denote by a circle inside of the big square. The big square is listing everybody. And then right away from this Venn diagram, we can tell that there are 62 people that aren't doing archery, which would have been almost impossible to figure out without the diagram. Okay, maybe not, but there will be some that if we don't draw a diagram, we won't be able to figure them out. So that's our event 8 who do archery. So the number of people that do event A, so this little n in front of that is a function saying how many are doing archery. The big rectangle U represents the entire thing, and inside that rectangle there are two parts. There's A and there's not A, and those two things add up to 100 in total. And if you were doing some probability based on this, if you wanted to figure out the chances that a student was doing archery, well, that's the number that did archery, which is 38, out of the total of 100, or you'd get 19 out of 50. Complement, notice it's not complement. It's got an extra E in there. It's not like you're being nice to A. Is denoted by A with a little dash. Depending on, sometimes you'll also see it A with a bar over top of it, depending on what you take in university and what different notations in different books. But we're going to donate it with a little dash after the A. And it's the probability that A does not occur. So if we're looking at our example above, and we wanted to figure out how many people were not doing archery, we could write it as the number that don't do archery was 62, still out of the 100 people in total, or 31 out of 50. Here is a crazy result. The probability of doing something plus the probability of not doing something is equal to 1, or 100%. So, for example, probability of flipping a coin and getting heads or not getting heads is 100%. And you can win every time on a flipping if you do that. I choose heads and not heads. I win. Usually they don't let you choose two things. But if you do get a choice of choosing two things, that's the best way to win. Roll a dice. I'm going to choose one and not one. But we end up using this idea a fair bit for percentages. If, for example, you know that there's a 32% chance that it's going to rain tomorrow, then 1 minus 0.32 tells us it's 68% chance that it won't rain. And sometimes it's going to be easier to figure out the complement than it is to actually figure out the probability, which we sort of used last year in permutations and combinations. Sometimes it was easier to figure out something not happening than it was to count all the ways something would happen. The intersection of two events, and here is the notation for writing it, and the way that we say it is we're looking for where both events are true, and the English word we use for that is and. I sort of use that to remember because I think this symbol kind of looks like an A, so it helps me remember that it must be and. So a question might ask, what are the chances of this and this happening in our Venn diagram? That's only where both of them occur. For example, I could do a survey, and I could ask how many people like pizza. And there would be our whole class and our pizza circle. And then I could ask this whole class how many people like soccer. And that would be another circle. Now, there's a chance that there's someone in this class that likes soccer but doesn't like pizza. And there's a chance that there's a person in this class that likes both soccer and pizza. And there's a chance that a person likes pizza only. And there might be people in this class that are like, I don't care for pizza or soccer. I just like my KFC and football. Okay? So, but if the question was, if you randomly selected someone from this class, what is the probability they like pizza and soccer? You'd only be looking for the people that answered yes to both. So here's our archery, and then we have badminton as well. Don't mix those two sports. One person on one side with badminton racket, the other person has an arrow on the other side. Not a good combination. What would that sport be called? Badmintery or archminton? Archminton. One person serves the bird up in the air, the other person tries to shoot the bird out of the air. You play until either one person dies or you're smart enough to figure out that you shouldn't play anymore. So again, we set up our Venn diagram with a big rectangular box to represent all of the events. There's our badminton players. No, these are our archery players in blue. Badminton players in red. There's 100 students in total. Now, when we draw this, we end up separating our Venn diagram into 4 different sections. Hope you can see them. There's one here, there's one that's only archery, one that's only badminton, and one section that's both. We look at the data that we're given. We know that all 4 of those sections are just going to have to add up to 100 because there's 100 students in total. We're given that 38 do archery, but I can't write a number 38 in here because that's broken. The archery circle is in 2 sections. But since I know 16 do both, I can put a 16 here in the middle. And now since 38 do archery in total, how many only do archery? 22, because 22 plus 16, now inside my blue archery circle is 38. 30 play badminton, leaving 14 here, so now inside my red circle, which is badminton, I have 30. Now, if I take my all three of these numbers together and add them up, I get 52. Means 48 students value their lives and don't play Archmonton. Now we have to switch the words around here. Take out the word volleyball here, because our diagram doesn't make sense with that. Add the word archery. Quickly change this so you never notice whatsoever that I ever made a mistake. Perfect. Can't even tell that the text changed at all. Yes. Mm-hmm.
If you're taking 16 from both of them,
Yes.
why do you take 16 from both of them if there's only 16 in the middle? Wouldn't it be?
Those 16 people in the middle, right? Those 16 people in the middle, they're part of the badminton circle. So they make up part of the 30, meaning that there's 14 left that still have to play badminton. Does that make sense? And those 16 people are also part of the archery circle. So that would leave 22 other people. Yeah? Awesome. So if we want to find the probability of A and B, probability of archery and badminton, that's those 16 people out of 100. Because you still have 100 students, but only 16 of them which reduces to 4 out of 25. But I kind of like leaving the fraction as 16 out of 100 because it represents. Now you want to pick someone at random. Now this first question, did we need the Venn diagram based on the information we're given to begin with? We were told there were 16 people that did both. We don't really need a Venn diagram to figure out that probability. But now if you wanted to find the probability of doing archery and not badminton, what is that? Well, we're looking for the intersection of archery and not badminton. So what I'm going to do is I'm going to color code things here, and I'm going to see if it helps you see where that intersection would be. I'm going to use highlighter. Let's go purple highlighter. Here's my archery circle. I'm going to color it in. Oh, this might be too dark. Maybe I don't want to use, no, I don't want to use that highlighter. Not happy with that at all. We're going to go to different kind of pen. White's probably a bad color. Gonna bright, no, that's, there we go. We're gonna have it a little bit transparent so you can still see. Okay, let's try this out. Can you see that? Kind of. So that green is archery. Now I'm going to color not badminton. Can you see that not badminton would be everything outside of the badminton red circle? So when I color outside of the badminton red circle, I should have used something different than green. Yep, not happy with the coloration of this. We're going to start all over and choose not quite green. So there we go. We're going to choose blue might look nicer. I'm going to make it a little bit more, less see-through. Let's see how this looks. Oh, beautiful. That is so much nicer. So that is archery. Not badminton is outside here. And the reason I wanted to do this is you notice that when I color over what I already colored, it gets darker. Can you see that? Isn't that cool? Oh, I love coloring. such enjoyment. Now, remember that this symbol means and it was the intersection. So by coloring it twice, can you see that one part got dark? Because that's where the two were intersected. How many are in that? Our probability of A and not B, there are 22 in that circle that got colored twice. That's the intersection between A and not B out of our 100 total. This question wouldn't have been as easy to answer just by reading our question. Our Venn diagram really helps us see what is the part that's not in B and also in A. That's only this section right here where the 22 is. Oh, very fun. Okay. Is everybody done coloring? I know I hate to move on. The union of events and we say or. If I had asked people before if they like pizza or soccer, if you liked soccer, you would have to say yes, because you like soccer. If you like pizza, you would have to say yes. So it's going to be all three sections, whether you like only pizza, whether you like them both, or whether you like only soccer, you would still say yes. The problem with these questions is most people like to clarify. Right? If I would ask Ben, are you a boy or a girl? The answer would have to be yes, but you'd probably want to clarify. You just feel the natural need to clarify in a question like that. Normally, people don't just answer yes to those things. And so students find these kind of questions hard because they want to clarify. They don't want to just accept that the answer is yes to all three of those. They want to be, no, I like pizza only, just so you know, I don't like soccer. You don't have to tell me that information. I just asked if you like pizza or soccer. And if you like one of those, both of those, you have to answer yes. The way that I remember this symbol is I like to think of this as A or B. And I find that helps. So the and one kind of looks like an A. And A or B kind of fits. So now we can go back to our diagram, find the probability that a student does archery or badminton. Well, that would be all three of those sections. And it's 52. Okay? What's a mistake that people do? They add 38 plus 30 and say 68. But what have they done? They've counted these 16 people twice then. So there's only 52 of them. The probability of A or B is 52 out of 100, and you could reduce that to 13 out of 25.